Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we are looking at a subject software engineering, and for today's session I will be describing on a continuation with requirements engineering process. The major learning objectives that we have planned for today's session are to manage requirements process, to describe the challenges of eliciting various requirements, to introduce various methods of how requirements can be analyzed. If you recall from our previous session, we have looked at requirements development over 4 different processes. One is on requirements elicitation, requirements analysis, requirements specification, and finally validating on those requirements. So as part of requirements elicitation, stakeholders, consultations, reviews on context normalization are the basic things that has happened for eliciting all the requirements. But to analyze on those requirements, we may have to plot some burn down charts, we may have to have some diagrams, which is at most necessary to build a design system. And to give a complete specification, we may have to structure those analyzed system in terms of a documentation, which I have said it to be as SRS documentation. And finally it is to be validated, where the identification of omitted, redundant and inconsistent requirements are considered. So this happens at one stage of requirements engineering process, which is called a requirements development phase, where there is another stage which looks after the complete of management of requirements, where we would concentrate on the traceability of requirements. In case if there is found to be some error or prediction of error that is going to happen on the software, then it should be traceable. Either it should be backward traceable or forward traceable. So traceability of requirements track where the requirements are to be met. Not only that, towards these requirements management, I may have to look at change management also. So during the phase of maintenance, there might be possible amount of changes that can appear. So requirement maintenance and propagation requires change management and probably fulfillment, which can result in confirmation of successful completion of requirements. As part of requirements elicitation, we have major challenges that are to be focused. So it has been categorized under 3 epidemic syndromes. The first syndrome is supposed to be called an yes but syndrome, which is very common in today's scenario. If you seek in some help from some of your friends, they would say generally for that particular problem first an answer of yes, but rather they will project a word of but, they will specify a constraint. Working on these particular constraint, then it takes us to a dilemma. So if it would have been an answer of yes alone, then it would be confirmed on whether to proceed with or not, but having incorporated the constraint or having mentioned the constraint, it leads us to a dilemma. So elicitation process is something like that. Or the second syndrome, which is supposed to be undiscovered ruin syndrome, where the search of requirements is like a search for undiscovered ruins, which is something like the more you find, the more you know remain. This happens many a times when we search on Google. For every document that we search, Google hints us with say 2 lakh documents retrieved for a particular keyword. It is not ultimately we search on those 2 lakh documents, but then we select the first 2 documents or the first page to a maximum. It is primarily because of the reason that we page rank it and document is ranked. So we rely saying the first 10 documents would be majorly or the most accurate of the keyword that we have mentioned. So, the more that is being projected, that takes us to a dilemma. And the third syndrome is supposed to be user and developer syndrome, where we have a communication gap between the user and the developer. So, these kind of requirements elicitation bridges the gap of these three syndromes. Now, looking at the data, to talk about the data, we have two different classes of data. One is to talk about quality and quantitative data, the other one is on the structured and unstructured data. If you take up quality data is something like, I took a cup of coffee today, or I drink coffee every day, whereas quantitatively I say I drink 4 coffees every day, where I mention a discrete value which is purely counted. So, 4 is a number which is to present the count of how many coffees I had on that particular day, whereas it either could be a discrete information or it could be a continuous information, where I can say as a continued information I take 80 grams of coffee every day, which is a measured value. So, how much I take as an input. So, these quantitative data provides us with a numerical information, whereas qualitative data provides us with a descriptive information. Likewise, the same data can be projected in a structured or an unstructured format. Structured data provides us with a high degree of organization, such as relational databases. Relational databases project every of the data that has been presented into a tabular format or a relation format, a column wise and a row wise value, whereas unstructured format of data is just an information that is difficult to organize using a traditional mechanism, where we understand it in terms of paragraphs. Now that we will try to understand what are the various ways in which we can collect these data. One certain format that we can have is direct interview with the stakeholders. So, by interviews we can have a face-to-face communication with the stakeholders, try to understand what are the points that they wanted to have as part of this project development. But then, because of these interviews, there are several pros and cons. If you look at the advantages of going by interviews, interviews provide us with rich collection of information, uncovers opinions on what the stakeholders thinks about this particular feature, the feeling, goals, as well as some hard facts that can be uncovered as part of the software requirements. The other advantage could be this can review in detail. This review can happen face to face and adopt follow-up questions to what the person tells you. So, anything that needs to be clarified can be clarified right at the moment, whereas there are large disadvantages in terms of amount of qualitative data that can be analyzed. Not as many people from various parts of the company are interviewed. So, in our opinion, company has different portions, say manufacturing unit will be there, warehouse unit will be there, there will be a delivery unit, there will be another tester, there will be a quality team. We will not be able to take up individual opinions from different team aspects, but then we will be collecting information from many a times from one person or from a maximum of 1 or 2 people. So, that may lead to a problematic issue. And the third disadvantage would be on follow-ups that are required for clarification. Finally, interviewing is a difficult skill to the master. So, apart from interviews, what are the various other methodologies that we can adopt are, we can prepare a questionnaire, having understood initially what the customers or what the stakeholders require. We can prepare a list of questionnaire by where we can ask them with the list of inputs. We can understand on their background reading also, so which department requires what sort of information. We may collect the data from introspection also. We can collect the data from social analysis relating to similar type of projects. We can even conduct some brainstorming sessions where from we collect inputs from different sources. We can have a storyboard, something like in user story. We can collect have storyboarding where individual opinions are being collected. We can develop a prototype by where we can collect the inputs from the stakeholders, and we can conduct role playing meetings. We can have a requirements reuse also, but then this requirements reuse, as we have mentioned, it would be a costly affair. After collecting all these requirements, now that it is time for us to specify on these requirements. So the method that are to be adopted for requirement specification are: description in natural language is too complex, so we cannot afford to have requirements that are misunderstood. So in terms of specifying all these requirements, we may have to either project it in format of pseudocode, finite state machines, decision trees, object oriented modeling, and entity relationship diagrams. So these are few of the methods that we can provide the specification with. If you have a doubt on what a pseudocode would really mean, this pseudocode attempt to combine the informality of the natural language with the strict syntax and control structures of a programming language. So this becomes an imperative statement. A limited set, typically not more than 40 to 50 of action oriented verbs will be used as part of this pseudocode. Decisions are majorly represented in terms of if then, if, else, end if structure. Iterative activity is represented within the loops, and it will be mostly of do while format or a for format. This is a standard example of a flowchart where I want to drink a cup of coffee or a cup of green tea or so. What should be the procedure that I should adopt with, either in terms of flowchart or in terms of a pseudocode I can plot with. So this is the structure of a pseudocode. From this we can clearly picturize rather than projecting it as an unstructured format. This structured template would specify what needs to be clearly worked with. The second methodology for specifying the requirements engineering is by plotting a finite state machine. To basically understand on this finite state machine, a proposed machine that can be in only one of a given number of states at any specific time. In response to the input, such as data entry from the user or an input from the external device, the machine needs to effectively convert all these inputs into other states and then generate an output or carries out an action. Both the output and the next state can be determined exclusively on the basis of understanding the current state and the event that caused this transition. In this specific way, the system's behavior can be said to be deterministic. This is one such example of a finite state machine where on a traffic signal or on a road I can instruct the driver whether he has to go straight. State 0 mentions a straight, there is a left signal, there is a right signal, and drive curving left, ignore sensors, it ends the time, so it goes back to the previous stage. Whereas if I take a right signal, then drive curving right, ignore sensors, then it goes back to the previous state. So this gives basically the state wise explanation, or otherwise the requirements can be very well understood from plotting a decision tree, mostly of yes or no type. Requirements that deal with the combination of inputs, different combinations of those inputs lead to different behaviors and outputs. So the combination like if then else statement clause quickly becomes twisted, especially if given this sort of an example. So if the customer is not very satisfactory, he complains, he does not complain, service representative takes it as a problem solved or problem unsolved and reaches the satisfied customer. If the problem unsolved, it seems it is tending to or marching towards dissatisfied customer, either the problem can be escalated or it can be given up, or otherwise if he does not complain, it seems he is a dissatisfied customer in the beginning. So that is one way of giving a decision based understanding. The other understanding could be of the format of object oriented modeling, where we plot different use case diagrams primarily in terms of a class diagram, sequence diagram and so. So this object oriented modeling helps the requirements involve a description of the structure, relationship among entities within the system, and it's often beneficial to use object oriented models to fully describe the behavior of the system. So this gives a clear intention of person, either could be a student or a professor. Between a student and a professor it is a one-to-one relationship, and both of them are supposed to be a person class, and it can also be plotted as a sequence diagram. This is for another example where the customer gets into a login screen by logging in, then it is to be validated using a security manager and then checks all the user details. User details are then validated and the result of it has been provided. So this can be a simple example towards banking system. So these are various representations that we can specify towards requirement plot. Not only that, we can even mention it as an entity relationship diagram. These entity relationship diagram are highest level of architectural view, which can give a complete representation of the relationship that can happen between two different entities, between an employee and a department, to which department he works on and the date in which he has started working and what is his position. These includes a structured data by where I try to plot all the entity attributes. This gives a clear understanding of the specification of plotting the requirements. So by where, after completely specifying all these requirements, we try to understand clearly on over different plots, we understand what the customer is about to specify. So now that we don't have a communication gap between the customer, and we can satisfactorily proceed through the next level of design. But while working on this, there are some non-functional requirements that might pop in. So those are supposed to be the quality requirements, quality measures for well formed requirements, like whether are these requirements correct, unambiguous, complete, consistent, verifiable, modifiable and traceable. Let us look at each and every point in detail. By correct requirements we mean if all the stated represents something required of the system that is to be built, whereas unambiguous requirements present us with a subject to only one interpretation. Requirements can be interpreted differently by developers, users and other stakeholders. Completeness, all these significant requirements of the concern to the user, including the requirements associated with the functionality, performance, design constraints, attributes and external interfaces. Consistency right from the beginning till the completion of the requirements plot, where there be any consistent activity that is maintained. So there is no subset of individual requirements described within it are in the conflict of another, and all the requirements that we have plotted in the beginning should be verifiable, that is testable. Create appropriate test procedures to carry out the verification. As I have indicated in the previous sessions, we should be able to generate test cases well ahead when we are plotting the requirements. So these should be verified first, then we go for another set of verification with the customer. And the requirements that we have projected in the beginning, some of the requirements need to be modifiable also. So adopting to the change of requirements can be made easily, completely and consistently, while retaining the existing structure and the style of the set. Not only that, to accomplish the quality standards to be maintained during the software development, we have to maintain the traceability constraints. So origin of each of its component requirements need to be very clear, and if there is a mechanism that makes it feasible to refer to that specific requirement in future development efforts. And sometimes these are to be understandable also. User and the developer communities are able to fully understand the individual requirements and aggregate the functionality implied by the set. so as to complete the design process. Requirements validation requires utmost traceability. If you look at IEEE's 1994 document, which provides a complete compounding definition of traceability, where the ability to describe and follow the life of a requirement in both forward and backward direction. As I have already indicated, traceability either should be of a forward format or it should be backward traceable also. Traceability is important, and the importance of it increases where the rate of change is high. So whenever there is a change of requirements that need to be adopted, traceability helps us a lot. Sometimes requirements are volatile. There are two classes of requirements traceability, as I have already mentioned. One is on forward traceability, the other one would be on the backward traceability. In forward traceability, each input to a phase must be traceable to an output of that particular phase, whereas during the backward traceability, each output of the phase must be traceable to the input, the otherwise around. So output that cannot be traced to the input are extra unless it is acknowledged that the input themselves were incomplete. Let us look at a simple example of a traceability matrix. The need, which is supposed to be the output of that particular component, has been given. It is compared with the feature that are provided in the initial cases. If that has been met, that has been marked. Need 2 for the feature 2 has been met, so that has been marked. Likewise, I can come out with a matrix which says the product features traces the stakeholders need. Whereas the other case around, after having plotted the use cases, that is the output, this output is traceable from the product also, where use cases are plotted and features are being listed. We look at these two cases. And as a last case, these requirements are to be reviewed. So there should be a peer group which should review on all the complete list of requirements presented, agreed upon both by the customer and the development team. So a group of people who analyzes on the requirements, look for the problems, meet and discuss the problems, and agree on actions that are to be addressed during these problems. So this review is a very formal meeting headed by a leader. It is not like an agile process. Not only to look at the errors, but also to check for the whether it has met all the standards or not. So requirements review happens by this process. We plan for a review, we distribute the documents, prepare for review, hold review meeting, follow up on the actions, and revise the document if in case there are supposed to be a major revision. So this is quite normal process of requirements review, where anything that has been prepared by a customer in conjunction with the customer and the developer, this has been presented as a document to the entire team. The team will review on what has happened so far, and they will prepare a review meeting. So this meeting comes up with the actions that are to be taken, necessary action. So a follow-up meeting relating to some issues that has popped up during the requirements engineering requires revision in the documentation also, because this documentation at most bridges the gap between the developer and the customer. So anything that has changed on the requirements, review helps us identifying where the changes happened, and subsequently that has to be documented, which will be provided at the end stage. In summary, in this particular lecture, we have learnt about the requirements engineering process, where we have started saying about eliciting all the requirements, tending to analyze on the requirements that we have elicited. Maybe the requirements will be in the format of an unstructured way or in a structured way, or it can be of qualitative data or a quantitative data. Now that we may have to analyze on the entire data, further it has been given for mentioning its specification, and it will be validated. So this is a standard flow that we will progress with during the requirements engineering phase. But not only that, we will consider parallelly another phase which is to be managed So, the requirements are to be managed in terms of traceability and changes that are to be adopted. Not only that, we have looked at the different methods for converting all these requirement specification, and we have looked at the non-functional requirements of mentioning or maintaining the standards that are to be adopted in terms of, say, consistency, in terms of completeness, in terms of traceability. Quality standards are to be adopted while we are plotting with the requirement specification. And finally, whatever that we have documented, whatever we have prepared so far as requirements need to be reviewed. So, this review helps us in identifying where is the possibility of error that would come into real picture and how it can be altered. Thank you.